Okay, we are in integration by parts. If you could remember differentiation, that's product rule of differentiation, that's the derivative of a product, maybe fx, two functions fx. If we are asked to find the derivative, the, the answer is always differentiate, that's keep one constant, keep one function constant, differentiate the other. After you add it to the other one, you keep the other function constant and multiply by that. If you could remember, that's our product rule. Keep differentiate plus keep differentiate. That's it. So if we decide to move this derivative to the other side, is now integral. So we now see that fx times dx, moving this to this side, is now integral of everything. Dx. Yes, that's, differentiation is the inverse of integration. So going to that side is now integral. So we now have integral of all this. Okay, if we decide to open up, so if you open up this, it means that we should integrate each of this function dx plus integral of gx f prime x dx. Yes. So what do you notice? If I decide to make this the subject of formula, so if I decide to make this the subject of formula, so if I decide to make f x g prime x, just choose anyone, make it the subject of formula, is now equal to fx times gx minus integral of, you get, I'm making this the subject of formula, so this goes to the other side, equal to gx f prime x dx. So this is our integration by parts. Yes, I'm trying to say that if you now let u be fx, we can, and v be gx, you now see that this is now integral of u times dv. Yes, because if you differentiate this v with respect to x, you have dv, that's g prime x dx. Do you get the logic? If I differentiate this, I have f prime, that's du dx is now f prime x. So making du the subject of formula is now f prime x dx. So we can now write this as uv, that's integral of u dv is now uv minus integral of v du. These two are the same because u is this. If you differentiate this, dv is now g prime x dx, which is this. So this is our integration by, that's the formula for integration by parts. But there is a little problem here. The major problem here, which one is u and which one will be dv? That's the major problem students facing. So how do you know which one? I'm saying that if you are given integral of u dv, that is uv minus integral of v du, that's our integration by that. So how do you know which of the function will be u while the remaining is dv? So there is one thing we call it Lipte. Yes, this is the order of u. So whenever you are given any integral of anything, the one you call u depends on this. the L here means logarithm. So if you are given logarithm function, so if you are given this, the one you assign you look out for logarithm function. That's the one you call. If you don't see logarithm function, this I, you look out for inverse trigonometry. That is like sine, arcsine of x. Do you get why this is maybe ln x or log log s? So anyone. So if you don't see the inverse log, you look out for polynomial. Polynomial, maybe x raised to power 2. Do you get x raised to power 5 plus? Do you get 6s? So something like that. If you don't see polynomial, look out for trigonometry. Trigonometric functions. And finally, if you don't see, look out for exponential. Like e raised to power x, maybe a raised to power x. Why this? Maybe sine x cos x. So these are these. So that is our order of u. So you first look for logarithm for. If you don't see, you assign u to inverse trig function. If you don't see, you move to polynomials. So that's how we solve it. Okay. So look at this question. So we are using this formula. This is our major formula now. Integration by parts. So once you are given products such that this integral is always something d something. So that's it. So that's the formula. So look at this. So we're asked to evaluate this. So we're asked to evaluate this. Okay, maybe. So solution. So the first one. So as you can see, we have a polynomial function and the trigonometric function. So with this, you go over which one is ahead. So we have polynomial before trigonometry. So we'll call you polynomial. Our u is x squared, and our dv is cos x dx. So in the formula, we have to use this formula now. In our formula, there is u dv, there is uv and v du. So we need to differentiate and integrate. So I will differentiate u and I will integrate dv to get v. So if I do du over dx, I have 2x. So if you now make du the subject of formula, I have 2x dx. And if you integrate dv, you have v. Integral of course is sine. So therefore now we're asked to find integral of x squared cos x dx, which is now equal to, we are now having u dv. U dv is now uv. Our u is what? X squared. Our v is sine x minus integral of v. V is sine x, and our du is 2x dx. Do you get the logic? I'm using this formula. Integral of u dv is now equal to uv minus integral of v du. So we integrate till we get to the last. So we're going to apply integration by parts again here. So we are going to do it 2 times. So we'll continue. So okay, let me just show that, because equal to, I'm continuing this x squared sine x minus, again we have polynomial function. and we have trig function. So our u is this. So integral of this is now uv minus vd minus integral of vdu. So I'm applying this integration by parts again. So our u is 2x. If you integrate sine, now remember dv is now sine x dx. So if you integrate sine, is now minus cos. So I have minus cos x minus integral of v. V is minus cos s, and our du, if you differentiate this, is 2. That's 2 dx. So we can rearrange this as minus that times that is plus 2x cos x minus 2 integral of cos x dx. Do you get? We'll bring out this constant minus 2 outside. So minus times minus is plus. So minus times plus is minus. So we now have the final answer is now x squared sine x plus 2x cos x minus 2 integral of cos is sine plus the constant, maybe k or c, anyone. So that's our answer. So let's move to the second question. Integral of ln x dx. We apply integration by parts here, yes, because if you look at this is the same thing as integral of 1 times ln x dx. Yes, so 1 is a polynomial. You remember why this is logarithm, so our u will be logarithm. So you see that then let's our u is ln x and our dv is 1 times the x, so which is the x, 1 dx is the x. So if you differentiate u, du ds is now 1 over x. That is therefore, you get du dx is 1 over x, making du the subject of formula is now 1 over x dx. Why integral? If you integrate dv, you have the integral of dx is x. Therefore, we are asked to integrate ln x ds, which is equal to, I'm using my formula, integral of u dv is now equal to uv minus integral of v du. So our u is ln x, our v is x, so x uv, so you have x ln x minus integral of v, which is x, times du, v du, and v du is 1 over x times the x, so which is the same as x ln x minus, this is 1, so integral of the x is x plus c. So that's it. Integral of x squared e raised to power x dx. So we let u, so polynomial comes before this, equal to x squared, and dv now is e raised to power x dx. So we differentiate u, du over dx is now 2x, so 2x dx, making du the subject of formula. And if you integrate dv is v, integral of e raised to power s is also e raised to power x. So we now have, therefore, the integral of x squared e raised to power x dx is now uv, which is x squared e raised to power x minus integrals v du, which is 2x e raised to power x dx. Do you get v times du is now this. So we still integrate more. We still go for the integration by parts. So we write this as x squared minus e raised to power x minus. So we'll call our u this. So if you differentiate, I'm applying this the second time, so you don't need to waste time. This is our u and this is our dv. So u, which is 2x, if you integrate this, is also e raised to power x minus integral of v. Our v is e raised to power x times du, which is 2. If you differentiate 2x, so you have 2 e raised to power x dx. So open up again, x squared, sorry, this e raised to power x squared e raised to power x minus 2x e raised to power x plus, we integrate this, do you get, plus minus times minus plus 2 will come here. So what is integral of e raised to power x? E raised to power x plus c. So that's our answer. So integration by part, just choose the one that you assign you, and the remaining is dv. From u you find du, and from dv you find v. You now use the formula, which is this uv minus integral of v du. So that's it. Thank you.